Okay, today we are talking about a complete home graywater reclamation system. So let's define some terms. Graywater is water from bathroom sinks, tubs, showers, and washing machines. Black water is water from toilets, urinals, dishwashers, and kitchen sinks. Non-potable water is water that is not safe to drink, cook, or bathe with. Potable water is safe to drink, cook, or bathe with. So we are only reusing gray water, not black water. So here is a complete home graywater reclamation system. It's a 2-tank system. The first tank you see here is the surge tank. That's where all the raw untreated gray water comes into the system from your washing machine, bathtub, shower, and bathroom sinks. And there is a float switch inside that surge tank that as the float switch floats up as the water level rises, it'll turn on the filter pump and pump the water through a 3-stage filter. They're cartridge filters. The first one is a 10-micron sediment filter. The second filter is a 5-micron granular activated carbon filter. And the third and final filter is a nanofiber filter, although you could use a reverse osmosis filter, and that's mainly for getting rid of the soaps in the gray water. However, it gets rid of also a lot of other contaminants in the water as well. Each of the tanks has a UV sterilizer light inside the tank. There's also an aeration pump that is constantly blowing a small amount of air through air stones submerged inside each tank to constantly aerate the water in both tanks. That way the water can never grow stagnant. As the water passes through the 3-stage filter, it goes into the supply tank. And whenever you flush your toilet, the supply pump is a shallow well jet pump. It will turn on and supply treated gray water to flush and fill your toilets. It can also be used for landscape irrigation. However, I don't recommend it because unless you have a drought-tolerant landscape that requires little to no water, you're going to burn through your treated gray water very quickly if you're trying to irrigate your landscaping and flush your toilets. And if you're even using your treated gray water to, let's say, supply water to your washing machine, you can see how you'd very quickly run out of treated gray water. So instead, I would recommend using a rainwater harvesting system if you want to irrigate your landscaping. I'd still highly recommend a xeriscape landscape, drought-tolerant native plants, decorative river rock, etc. And that supply pump is a shallow well jet pump. It's controlled by a pressure switch. So when you flush a toilet, for example, that pressure switch will detect the difference in pressure and cause the pump to turn on until the pressure switch is satisfied, then the pump will turn off. There's also a float switch inside of the supply tank to protect the supply pump in the event that the water level gets too low in the supply tank. It's not going to turn the pump on, cavitate the pump, and damage the pump. There's a second float switch in that supply tank that is connected to a 120-volt solenoid valve, a freshwater makeup valve. As the name implies, that makeup valve is only to make up water inside the supply tank in the event you're not producing enough treated gray water to meet the demand. That's why it's critical to make sure you size your tanks properly. I'd rather err on the side of caution and size them a little bit bigger. So how do you determine what size tanks you need? We'll cover that later in this video. So that pretty much covers all the main components of the tanks and the pumps. Let's take a look inside the control panel now. So here's sort of a simplified wiring schematic. You see we have 120 volt power coming in on the left-hand side, plugs into a GFCI outlet or a GFCI protected circuit. Ideally, you want a dedicated circuit just for your gray water system. So you got a hot, neutral, and green ground wire coming in. Your green ground wires all land on the grounding terminal here. Then all your neutral wires all land on the neutral bus bar up here. And there's little metal U-shaped connectors that connect each of the screw terminals on the neutral bus bar. And then you have your main black hot wire coming into your disconnect switch. And then it goes up to your fused terminal blocks. And you can see each terminal block is daisy chained together to get 120 volts. And there's a fuse inside each one of those blocks. You can see the little green indicator light. So when the power is on, the green indicator light will turn on, giving you a positive indication that the power is on, the system is on. And then you can see how all the wires are connected. You got a hot wire going out to each of the components, both UV lights, the air pump, and then again, you can see you have your float switch that controls your filter pump, on and off functionality, another float switch that protects the supply pump, and then there's another float switch that is connected again to the solenoid valve. And all of these components together need to draw at or below 80% of the circuit capacity. So the pumps that I spec'd out and the UV sterilizers I spec'd out draw below that 80% capacity that the NEC requires. You can't draw more than that on the circuit. And again, it's plugged into a GFCI outlet. And this air gap fitting is a plumbing requirement, so you don't accidentally have a situation where you can have gray water getting siphoned back into the fresh water supply line. So just FYI on that. And in this model, you can see we simply teed into the existing sewer pipe in this house. We installed a Y fitting. So where the cleanout was, we simply moved the cleanout up a few inches, installed the Y fitting, reinstalled the cleanout so it can still be snaked out if necessary. There's a closer look at the cleanouts on the main sewer line for this house. So you can see what I did there. I just added that reducing Y and then re-added the cleanout plug on top of that Y. And then the branch on the Y is where the overflow from those tanks is plumbed. So in the event that you make too much gray water, it can go out the overflow, out the drain. Another option is this here. If you have a floor drain, you can just have your overflow pipes go directly to your floor drain. The floor drain already has a built-in P-trap. So that saves a little bit of work and cost and fittings. So you can see a better view. You see the control panel there up top, the air pump, aeration pump sitting on that little mounting bracket for the filters. And I use bulkhead fittings everywhere you need to have an inlet or outlet from the tanks. And where the raw gray water comes in the surge tank, there is a metal mesh screen in there to capture large debris like human hair or cotton fibers from the washing machine. And this is what you would install behind your washing machine. So you can see the black hose from your washing machine goes into this three-way ball valve. You need to make sure you have an air admittance valve to serve as a plumbing vent. And I bolted it to a wood board, bolted the wood board to the studs in the wall. That three-way ball valve allows you to divert the water either to your Greywater Reclamation system or directly to your city sewer or septic tank, just with the turn of that ball valve. So this is also another option. If you don't want a complete whole house gray water system, you can do one of these manifolds behind your washing machine and divert the untreated gray water directly out subsurface to your landscaping. That's what it looks like in real life that I plumbed on my washing machine. So I labeled all the pipes. You can see the air gap, air admittance valve vent there. So you can see to the left, it goes out to the graywater system. To the right, it goes down the pipe to the city sewer system. So I hope that makes sense. Another option too is you could harvest the AC condensate or drain water from your dehumidifier and have it plumb to your graywater surge tank as well. So let's talk about water quality and water monitoring. You can buy these home test strips. This one is available on Amazon.com. They're readily available everywhere, pretty much. They test for heavy metals and other chemicals in the water, but they also check for things like pH, alkalinity, turbidity, total dissolved solids, that kind of stuff. You can also buy a total dissolved solids battery-powered meter to check for that. Just if you want to monitor your treated gray water quality to see if your filters are working properly, if your system is working properly, that's an option. Another option is there are independent laboratories, and even your local state government may have a water testing program where you can send them a water sample. They'll first send you a water sample kit. Follow the directions. You send them the samples, and several weeks later, they'll give you the results of those samples. The cost and time frame is going to vary depending on where you live, from state to state, from municipality to municipality. Or again, you can find an independent water testing lab online if you Google it. So what's the process? Let's talk permitting. So at the time I lived in the city of Temecula in California. I had to pay $80 for a plumbing permit. I first had to fill out a permit application, pay the $80, and one of the requirements was I had to produce an owner's manual and hang this inspection job card in my house. You can see where the inspector signed off on it on his final walkthrough inspection. And so here's the owner's manual I created. I've grayed out my personal information, obviously. So table of contents. And they require things like a site plan, a plumbing plan, and a brief description of how the system will be used. And I included Chapter 16A from the California Water Resource Systems, reuse systems. And it has all the legal verbiage in there about gray water systems. And again, every state's going to be a little bit different. I cannot guarantee the procedure in your state, what you will have to do, not have to do. If you live in a rural area that doesn't require a plumbing permit for a gray water system, I couldn't tell you that. You'll need to check with your local authority having jurisdiction. So again, here's a site plan. And again, I've grayed out all my personal information and site information. But there's some basic things you need, like the arrow pointing north. You need to show where the equipment is in relation to your house. And then you need a plumbing plan, which is pretty similar to the plot plan. But you can see the actual equipment and the arrows indicating directionality of flow. And there's a key identifying all the major components and how they're connected together. And you can see where the inspector signed off on that. And then a brief use of how the system's going to be used and works. But again, depending on where you live, the inspector may say, hey, you need to have earthquake straps around your water tanks. Or they may require that you have a backflow preventer or anti-siphon check valve on your fresh water makeup water line, for example, instead of just an air gap. Again, every authority is going to be slightly different. And you also want to cap off and completely shut off the freshwater supply line going to your toilet. You'll remove the supply line from the fresh water valve at your toilet, and you'll plumb in a new separate water valve and separate gray water line that will attach to the supply line on your toilet. So that way there's no chance of any cross-contamination between your gray water line and the existing potable water line, if that makes sense. So some key things you'll see in this 3D model. The P-traps are a requirement when you're connected to a sewer or a septic tank, and you do need to have those overflow lines that you see in this graphic. And then you need air admittance valves as vents after the P-traps. And you can see I also have air admittance valves on each tank themselves, so the pump can pump the water out properly. And then I have union ball valves at all of my connections that you see. Makes it easier to install the system. And the ball valves allow you to shut off the water when you do maintenance or repairs. And you also want one-way check valves at each of the inlets on each of your pumps. So you can see there's a one-way check valve here on the filter pump inlet, and there's a one-way check valve here on the inlet of the supply pump. I hope this information helps you. You also want to make sure that you label all your piping with a Greywater system sticker, and then you need to label or hang a sign at each of your toilets that you're flushing and filling with gray water as well. Also want to make sure that you turn off and cap off the water supply valve to your toilets and move the supply hose over to a new separate gray water supply valve. So that way there's no chance of cross-contamination between your gray water supply line and the potable water supply line. I hope that makes sense. Now, in regards to what size tank, how do you calculate that? What size filters, pumps, etc.? You first need to get a piece of paper or a spreadsheet. You need to write down how many people live in your house or in your building. How many showers do they take a day? How many minutes are each shower? What is the flow rate of your shower heads? What is the flow rate of the bathroom sinks, the aerators on the faucets? What is the gallon per flush rating of your toilets that you're going to supply with gray water? You need to identify specifically what are you using the gray water for, so you can calculate how many gallons you'll need to flush and fill your toilets, for example. Calculate how many gallons of gray water on average you produce per day in your household. And you can extrapolate that out. You also need to figure out how many gallons your particular washing machine produces with every load of laundry. How many loads of laundry do you do per week, per month, etc. Then you can start to formulate how many gallons total of gray water that you produce and that you use. And again, I find a spreadsheet or writing everything down helps. And then that way you can go ahead and buy your tanks and size them appropriately for the amount of gallons that you're going to produce and use. And the filters, I'd recommend 4-inch by 20-inch cartridge style filters. Now, if you're talking about a larger house with more people, you may have to upsize the tanks and the filters. Or this could even be applied in a small industrial or commercial application. But again, you would need to upsize the size of the tanks and the filters to accommodate the amount of gray water that's produced and consumed in that small industrial or commercial facility. So treated, sanitized gray water can be used for flushing and filling toilets, supplying washing machines, landscape irrigation. It can be used in the industrial setting for filling mop buckets, scrubber carts, water cooling tower makeup water, parts washer makeup water, closed loop wash racks, etc. And you want to mount it on a solid surface like a concrete slab. You don't want to mount it outside if you live in a cold climate that gets below freezing for obvious reasons. You don't want frozen pipes, frozen pumps. So mount it down in a basement or in a shed on a concrete slab or in a garage. And some municipalities may have you dye the water that is feeding your toilets. A simple way to accomplish that is those little blue hockey pucks that you can drop into your toilet tank That'll dye the water to accommodate that requirement if it's necessary in your area. Please like, share, subscribe, leave me a comment, and thanks for watching.